Hi, I'm Atul and I'm in London right now.
Hi, I'm Paul and I'm in Burnley, Lancashire at the moment. Okay, so we're going to look at gas calculations using balanced equations. The good thing about gas calculations is that we can just use the volumes of the gases. We don't have to calculate the moles because 1 mole of any gas is 24 decimeters cubed. And so we can just use the proportions of the volumes of gases to do the calculation. But anyway, we'll have a look at this. So as an example, 30 centimeters cubed of xenon are mixed with 20 centimeters cubed of fluorine. The gases react according to the following equation and assume the temperature and pressure remain constant. And it's asking us what is the final volume of gas after the reaction is complete. So they're all gases. So it's asking us for the final volume of all the gases after the reaction is complete. So what I would always say with any calculation is do it under the equation. So I'll place the equation over here,
Right.
stretch it out a bit. And I use what's called the ICE method. Now, most chemistry students are familiar with the ICE method from equilibria, but you can use it just for normal molar equations. And I'll show you how. So the I in ICE stands for initial. So we're looking at the initial volumes of gases. So we've got 30 centimeters cubed of xenon, 20 centimeters cubed of fluorine, and initially we've got nothing of the xenon fluoride. So then we look at the C in ice, which is the change. So we're looking at how much of the reactant is used up and how much of the product is formed. So here, because we've got less of the fluorine, and it's a 1-to-1 ratio, then that's going to be the limiting reagent. So that's how much xenon and fluorine are going to react. So all of the fluorine will react. The xenon is in excess. And because it's a 1-to-1-to-1 molar ratio, we'd form 20 centimeters cubed of xenon fluoride. So the E usually stands for what we've got left at equilibrium, that this isn't an equilibrium, it's a reaction. So I'll just put here, this is what we've got left at the end of the reaction instead. So you can see if we started with 30 centimeters cubed of xenon, 20 is reacted, we must be left with 10. All the fluorine reacted, so we're left with nothing. And we formed 20 centimeters cubed of xenon fluoride. So our total gas at the end is 30 centimeters cubed. And we see that that is option C. So for gas calculations from balanced equations, we couldn't do this with solutions or solids. We can just use the centimeters cubed. We don't have to convert them into moles when we're using gases.
Great, that sounds good. Yeah. So, if I suppose if you wanted to, you could still convert it into moles and do it method the student is familiar with already. If they are like a little bit unsure of what to do.
Exactly. Yes, they could use that 1 mole is 24,000 centimeters cubed and convert all these values into moles, but then at the end convert them back into centimeters cubed, and they get the same answer, but it would be a lot longer method of doing it.
Great. And also in this case you have to figure out which one is the excess, but it's fairly straightforward since you always get 24,000 cm cube in 1 mole.
Yeah, we've got, in this calculation, we've got to figure out, yeah, you can just go off the volumes to figure out the excess, because it's a 1-to-1 ratio. Whether it's a 1-to-1 ratio, the limiting reagent is the lower moles, or in this case, the lower volume.
Got it. Sounds good. Yeah. I look forward to the next video, whatever that might be.
Okay, thanks, Atul.
All right. Thanks, Paul. Bye.
Thanks. Bye.